Hello, and welcome to the latest video by Lacey Maths and Stats Consultancy. My name is Sean Lacey, and in this video I'm going to work through scripts that I would use on a regular basis when it comes to producing box plots in ggplot2. Like most of my videos on the Lacey Maths and Stats YouTube channel, they're very much driven by my own experiences of challenges and tasks that I would encounter in my own research and my own kind of work related to data analysis. And when it comes to box plots in RStudio, mainly using ggplot2 package, it would involve these 7 points here. So the first would be when you produce a box plot using ggplot, it doesn't by default give you the whiskers. So traditionally a box plot would be called a box and a whisker plot. So I'm just going to show you some script that will actually produce the whiskers for you if that's something that you're interested in. Like most of my videos, I'd be a big advocate of when graphs are produced that they should be labeled and scaled correctly. So I'm just going to show you the script that will help that for the box plot. The next thing then is I'm just going to look at showing you how to, I suppose, select some colors for the boxes in the box plot. The colors that I'm actually going to select will be have been chosen by my son Kieran, who helped me with the thumbnail for this video. Then I suppose when it comes to the box plot, like the box plot will be often a 5-number summary is what it would be called, as well, is where it would summarize your min-max values, your quartiles, and including your median. A point that's not included in your box plot is the mean point, and sometimes people like to see the actual mean point. So I'm just going to show some script that will output the mean point in the box plots as well. Then I'm going to look at the difference between a dot plot and a jitter plot as an overlay on the box plot. And that feeds nicely into when these overlay points are produced or created in the plots, that it could be of interest to label the points by a participant ID or maybe just label the outliers. And that pretty much gives the structure to this video. So without any further ado, I'm just going to, I suppose, jump straight in and start getting some data. So like most of my videos, I would use data that will be created randomly in RStudio. So the first thing that I wanted to do here is I wanted to create an ID variable. That's mainly to feed into the last points of this video of labeling points using an ID kind of mechanism. So what I'm doing here for this, I suppose, the data that's going to be is it's going to be 40 participants tested across 3 time points, and the participants are broken up into 2 parallel groups, which will have a low and a high setting is what I'm calling it. So I want, the first bit is to have the kind of the participant ID. So I'm going to label them ID dash, then their ID number. So 0, 1, 0, 2 up to 40 essentially. So that's what this for loop is going to do. Then the next bit here on my line 7 is, I suppose more my line 8, 9 and 10 is so I want to randomly select numbers in certain intervals, but I want those numbers that I randomly select to be reproducible. So I need to make sure that I need to set the seed in order for the numbers that I'm looking at here to be reproducible. For the first time point, I want there to be an outlier because it's mainly for the graph that I want for us to look at. So on the first time point here, there is 39 numbers randomly selected between 1 and 20, and then there's going to be an outlier at the very end of a value of 40. At the second time point, there is actually going to be 40 numbers randomly selected between 11 and 40. At the third time point, there is a value at the start of 11, and then I'm randomly selecting 39 numbers between 31 to 60. Then on my line, the line 11 here is where the factor is created, so that kind of between subjects factor, if you're thinking of going down the whole ANOVA route, which we're not doing in this video. There's just going to be, the factor has 2 levels, which has a low and a high setting, and each, I suppose, there's 20 participants in each kind of group. And then it's putting all that information together as a data frame. So I'm calling the data frame df, and this is what we get back. Now I'll just view that just so we can just see where we are, and this is what we have. So this is our data frame here at the moment. So you can see there's the ID measurement over on the left hand side. Then you have the factor, which has the 2 settings, the low and the high setting, and then there's the measurements across the 3 time points. The next thing I suppose is it's just trying to always kind of keep in mind good practice for statistical analysis. The factor measurement, I want to make sure it is actually a factor, that RStudio is treating it as a factor. And also, I'd like that with the measurement that has a low and a high setting, I'd like the order that the low goes first as opposed to the high. So I need to specify the order to the factor. So that's what line 15 is doing here. like most of the data that we have in RStudio, that we need it to be in a long format as opposed to a wide format. So the data frame at the moment is in a wide format, so you need to put it in a long format, and so that's what I'm doing here. I'm using the tidyr package and using the gather function, and that will give me this back here, so it's just loading it there as well. And I'll just view that so you can just see what we have there if anyone's new to the gather function. So this is what we have. So basically the data is now converted from a wide format into a long format. Okay. And now let's start. Oh yeah, the last thing then I wanted to do here is just the time measurements. So when you look at the data frame here, the long data frame, you can see time is labeled as time 1, T1, T2, T3. I just wanted to give them a better name, so I'm calling it time 1, time 2, and time 3. So that's all that's happening here. And if I just view the data frame, you can just see, look, that's updated then in that case, which just makes the graphs look a small bit nicer. And then I'm just making that time measurement. I'm specifying that it's a factor. Not really needed for the boxplot, but again, always just trying to kind of keep in mind good practice when it comes to the statistical analysis. And then I suppose the first step is essentially to produce the boxplot. Okay, so I'm looking at the default boxplot here. So I'm using the ggplot2 package. Then it's the ggplot function to specify the data frame. And then what I'm looking at here is I want my x-axis to be time. So that's going to be kind of the within subjects factor. The y-axis is going to be the continuous measurement, which is I'm just simply calling measure in this case. And then I'm splitting it all with respect to the between subjects factor. So it's going to be fill equals factor. Then I'm saying that, so this is kind of where I'm telling ggplot what, I suppose, variables to use. Then this is where I'm specifying like what plot we want. And then the last bit then is what theme I want to use. And I'll just fix that up here like this. And down on the bottom right hand side of my screen, you will see that the boxplot appears. Now, the first thing then that would jump out at me is that there is no whiskers to this, and I think it's quite good to actually have it as a box and whisker plot, even though we generally just call it a box plot. I think it's just good practice to have those whiskers on it. So that's where I'm going here really first, which is kind of the first part to this video, I suppose when you think of the 7 points that are mentioned on the PDF earlier. The first one was to look at putting in the whiskers, and all I'm adding in here is I'm basically using the same script that I have up here in line 29, but I'm just adding in stat_boxplot GOM equals error bar. Okay, and this will essentially put in those error bars, which is this, for us in this case, is actually going to be the whiskers. Now there's different kind of manipulations that you can do here to kind of to specify the width of the bar, as in the error bar, or the kind of the thickness of it. But at the moment, I just think I very rarely actually edit that, so I just leave it like this. And you can see over here on the right hand side of my screen that those plots appear quite nice, I would think. Okay, then labeling and scaling the axes is obviously super important. So here, what I'm looking at doing, so that's the plot that I have in the bottom right hand side of my screen. I'm calling P1 here, and now I'm just going to label the x-axis. I'm going to leave it blank. I don't feel I need time to be mentioned here because I'm calling each level time 1, time 2, time 3. So I don't need, I would feel don't need time here. The measure obviously should have its unit, so I'm specifying look measure as a unit. And then I'm scaling the x and y axes. I'm scaling just the y axis and increasing the text size. And this is the graph that I get back, which I would feel look is quite a good graph. It's nice and clear. What we can see is that there's an increase in the measurement over time. The increase in the measurement over time seems to be quite consistent with respect to the factor, whether you're kind of at the low setting or the high setting. That's kind of what we would see here. Okay, and obviously then that we have these outliers as well, which is something that's always worth exploring, and that's going to be something I'll finish up this video with as well. Okay, then the next bit then I suppose is you can just see here the default colors are quite I suppose strong. That it's only natural that you might be interested in changing the color to the boxplots. So I would have mentioned earlier that my son Kieran would have helped me out with this. So he would have picked olive drab 2 and steel blue as the two colors for the boxplot, which I think actually when you see them out, and you can see it on the thumbnail, they do come out quite nice. So all that's actually here is the additional. So I'm taking P2, which is the graph on the bottom right hand side of the screen, and then just specifying the colors. So here on line 42, I'm specifying what colors I want. So olive drab 2 and steel blue. And then here I'm saying scale fill manual. So I'm specifying that I want to change the color of the fill. And here I'm stating that it's the values of the color, which the color measurement is mentioned up here on line 42. And if I highlight that here, this is how it comes back, which I think is quite nice. I actually quite liked that, and that gives a nice bit of focus. So I suppose for the thumbnail, and those of you that might be just interested in how Kieran and myself would have formatted the thumbnail, what I just did, I suppose for the thumbnail, we just didn't want the outlier in it, didn't need the black dots, so I just kind of color the black dots white, essentially, so it obviously masks the outliers, but that's obviously just for the thumbnail. Got rid of the X and Y labels, got rid of the scaling on the Y-axis, and then said team void. Now the one thing that's additional, and that's why I just wanted to put, even mention this here, is when you do this script here, it doesn't actually remove, if I just highlight this here, this should work, it doesn't actually remove, sorry, you can just see here, I have that there, and let me do that one more time because I highlighted the plus there with that. So this is what I wanted. You can just see here, it doesn't actually remove the legend over on the right hand side. So that's why the team legend dot position equals none is needed there as an additional bit. And that's basically, I suppose, the structure for the thumbnail that we actually would have had. Okay, so look, thanks to Kieran for helping me out with that. And now moving on. So what I would have mentioned in the kind of one of the points we want to cover is, look, how do we plot the mean point? So what I'm going to do is I'm just going to go back to P3. So P3 is where we have this graph on the bottom right hand side of my screen. And here, all I just wanted to do is I just wanted to plot the mean for each of the groups. Okay, I'm plotting the mean, so I'm using the stat summary function, which is a nice function to do this. I'm saying I wanted to plot it as a point. And then here I'm just formatting it, saying, look, I want the size, the shape to be of 18, which has a particular shape. There's all these different kind of, I suppose, mapping of numbers to the types of shapes that you have. The size is 4, the color is red, and just this is the position of it, the kind of the horizontal position of it. And this is what we get back, which I'm not necessarily a big fan of the red or anything like that. I was actually being quite extreme with it, purposely being quite extreme, mainly for the purposes of this video. I don't know would I be as extreme as this if it was actually for my own kind of project work, but I think for the video it works quite well. So I actually couldn't remember what 18 was. So 18 was kind of this kind of slight diamond shape is what that is. The code 18 maps to, and then it's quite, I suppose it's nice that it's just mapping out the mean, because obviously if the mean is drastically different from the median, it's kind of giving you an idea that your data could be skewed, and that's going to be obviously something that's quite important and worth investigating. So that's that bit. Sometimes people like to have the points, so we'd say the participants' measurements overlaid in the box plot, and one way of doing that is by using a dot plot. So what I'm doing here is I'm taking P3 again, so I'll just put up P3. So I'm kind of leaving out the mean bit and going back to P3, and I'm including a dot plot. Okay, so that's what I'm essentially doing here is I'm including the dot plot of the measurements. So that's what we're looking at, the measurements we have. And this is just kind of basically formatting it that I want the points to be in the center. This is just the dot size, and this is just, again, the positioning of everything. And if I just pop that in here, you can see this is what we get back. I'll zoom in on that there just to kind of see it. It's fine. There's nothing wrong with this. I suppose the one thing what we're seeing here, if I just focus maybe up here at the top right hand side, is we had two participants that had a scored, or whatever we're measuring here, a value of 60, and obviously those 2 points are actually side by side here. Okay, so that's the one thing with this. When we do this as a dot plot, all the points are actually plotted, so you have them kind of side by side. The jitter plot does it a bit different, and it really, I to and fro between them, and I really do. Okay, it's not necessarily that I say, oh, I prefer one over the other. It really depends on what I'm measuring, and it depends on how many points I have. But it's quite common that you do see people to and fro between dot plots and jitter plots, so that's why I wanted to just do this here in the video. So what I'm doing here for the jitter plot is I'm highlighting, because what will happen here with the jitter plot is it will plot the points, a point next to your measure. You'll see what when it pops up here in a second, but I want to make sure that I'm still making it very clear where my outlier is, and you'll see why I want to do this now in a minute. And it's not what I would have done in default, but when I was putting together the script of the video, I said, look, that this would be a nice addition. So here, when it comes to the outlier, I'm coloring the outlier red, and I'm making the size of the outlier 5. Okay, actually, even if I do that first, maybe before doing this bit here, so we have this, and we don't, you see it here in a second, do P6 here, like this, and you get it up here, and you can just see, look, I'm just making the outlier standing out. That's all I'm doing here. But now I want to put it in as a jitter plot, and this is what we end up with. Okay, so the idea to the jitter plot, and it works out quite well. If you come up here to this top right hand side again, those two participants that scored 60, you don't see them as 2 points actually anymore. They're basically overlaid each other, which I think is quite nice, and I think it works out quite well. Here you can just see, look, this is why I wanted to color the outlier red. It's just kind of to distinguish the outlier, as in how RStudio is classifying the outlier, and the jitter plot. Obviously they're the same thing, but I just wanted to, I suppose, distinguish between them just using the script. That's all. Okay, that there's really no major need for the red bar, just demonstrating the jitter plot. That's really all the purpose for this is. Okay, now last two things then for this one is I have been asked at times, and when I'm working on projects, that when it comes to these points, that look, it'd be useful to know, look, who are the participants at each one of these points. Okay, so can we label the jitter plots or the points on this graphs with the participant ID? Okay, so that's it was a fair enough task, or I suppose fair enough thing to be asked to do. Okay, so what I'm just looking at doing here is I know it's messy at the start. Okay, and I'm going to kind of, I suppose, work through the script of how I generally would have approached this, but let's take it in stages first. So P6 is basically this jitter plot that we have here on the bottom right hand side of my screen. And what I'm doing here is I'm just basically including text over, and how I'm specifying it is the text is basically going to be the ID measurement, and it's going to be aligned with the jitter plots. Okay, so I'm going to just do that here. And this very messy, obviously, very, very messy. But this is what we get back. Now, this is essentially what it's kind of wanted. If we want to know, it is messy. I'm going to tidy it up a small bit here. But if you look at it over here, look, we have the outlier, and now we have the label next to it, so ID 40. Okay, so this is the participant, that is the outlier. Okay, but obviously, when it comes to all these points in the middle, they're very messy. And then the other thing when it comes to this graph is, if I was asked to kind of proceed with this graph, I would feel, look, I don't need ID mentioned everywhere. Okay, I don't need that. The ID dash, that could actually be removed. So I'm just going to show you a script that I would often use when I suppose when I'm tasked with something like that. So what I know I want here is I only want the so if I take that ID measurement here, I'll just run it off here just so we can see it. The ID measurement is ID hyphen or ID dash 0102 and so on like that. All I'm interested in is the last two characters to this. So what I'm going to do here is I'm going to use this as sub str function. And what this will do is it will extract just the last two characters. Now I'm specifying that I wanted to extract the last two characters. So I'm saying end last, I'm saying 2. And what I'm asking it to do now is to take the ID measurement, but just extract the last two characters. That's the function, that's what I'm going to do here. And have a new variable. So the new variable now is going to be df $part. So the new variable is essentially going to be part. And if I just run that off here, it just is a nice kind of short way essentially of just getting the participant's ID number as opposed to the ID dash bit. Okay, so just focusing on the actual number. So that's the function I would use on a regular basis. And now I'm going to run off the graph again. Now it's still going to be kind of messy because all the numbers are going to be there, but essentially going to run off the same graph as same kind of script that I did in line 61, except it's going to be $part instead. And this is what we get back here. And I do think that that's a bit nicer. Okay, I do think it's a bit nicer. Now you might look at increasing the text size. I'll show you how to do that now in a minute or two. It really depends now on why you're doing this, to maybe what formatting you would look at doing it. There's definitely a certain element of messiness to it. But if you're maybe involved in an exploratory study and the data analysis that you're doing is to help inform a future study, then these points could be something that are quite, labeling the points could be something that is quite important. Okay, so it can vary. It really can vary. But I suppose the one thing that would jump out at me with this one is what I would find my own self is that having all the points labeled does seem a bit excessive, but having the outliers labeled wouldn't seem that excessive. And you can see when you produce a box plot in RStudio or using ggplot, it doesn't label the outliers by default, while other packages that you would use, and I would do a lot of work in SPSS, they do label the outliers by default. So I just wanted to kind of finish up this video with just showing you a small bit of script to how you could actually label outliers as a default mechanism when you're producing box plots. Okay, so coming back here, so I'm going to use this function that it's going to be called isOutlier. So whether or not something is an outlier. Now how we classify something as an outlier is when you take your lower quartiles, so Q1 minus 1.5 into quartile ranges. If anything's below that, then it will be classified as a lower outlier, which is what we have over here on the right hand side bottom right. If anything, if you take your third quartile and add 1.5 into quartile ranges, then that's where you have an upper outlier, and that's what we have up here kind of in the graph as well. Okay, now this function is, I would have actually got it from the Stack Overflow, and you can actually see here, if you look at kind of, I suppose, put into a search engine, Stack Overflow labeling outliers of a box plot in R, you'll come across this function, which is quite nice. It does a really nice job of doing this. Okay, so this is just a function I'm going to use, that bit here. Now, what I basically want to do here is, I want to kind of create a variable that it will basically say if something is an outlier, then the ID measurement for that outlier will appear, will be saved, And if something is not an outlier, well, then it will be left blank. So that's what I'm looking at doing. Okay, so I want to create a new variable, which I'm calling, if I remember correctly, I'm just going to call it outlier. That's what I'm just using here. And it's basically going to output the ID if something is an outlier, or it's going to leave it blank if something is not an outlier. Okay, now this is, I suppose, the vision that I had for when I'm looking at labeling the outliers. So what I'm doing here is I'm going to use the dplyr package. Okay, I'm using the mutate function in that. So I'm taking the data frame. I'm looking at splitting the data frame, so using the pipe with respect to group by of factor and time, and then in creating a measurement, I'm going to call the measurement outlier, and that measurement that's going to be called outlier, I'm going to mutate it onto the data frame, the df data frame, so and it's going to be the new data frame. I'm still calling it df, so it's basically going to be the original with an extra column. And what it's going to do here is it's going to look at each measurement that they have, and it's going to determine whether or not if it's an outlier. So is outlier using this function that I would have got from Stack Overflow. If it's an outlier, then it's going to store the ID for that measurement, so what the participant's ID was. And if it's not an outlier, it's going to leave it blank. Okay, so it's quite a nice way of doing this. I haven't run this off yet, so I'm just going to come back here with this. So I'm going to use the function and then dplyr, load the library, and then using the mutate here like this, and this will get back, nothing came back here. So let me just, as in there was no errors or anything like that. So let's just view the data frame here, and you can just see here basically ID column, factor, the time measurement, the time factor, the measurement. This was the part, so that was the ID where we dropped the ID dash bit. And now look, outlier. So none of these points, now we know that there's two outliers. So where do we see that? Does it appear here? It will appear. Look, there's one outlier, ID 40. That's correct, because when I created the data set at the start, the 40 person was going to be an outlier at the first time point, which is what we're seeing here. And then the other outlier we know is at the third time point. Okay, so if I scroll down here a good bit, you're going to see, look, all those are blank, and look, there we have it. There's the ID 01, and that was the first participant was the outlier. And just as a bit of a refresher, how do I know that? If I shoot up here to the very start of where we set it, here is where I put the outlier for the first measurement, which is the 40 person, while I put the outlier at the very start here for the third measurement, which is going to be the first person. Okay, so that's how I know where those outliers are. Okay, and very simple then. So like anything in RStudio, it just takes a while to find the script, and once you have the script, you can use it quite easily going forward. So what I'm going to do here is I'm going to take P3, so I'll just put up P3 here. So this is P3 again, and now what I'm going to do is I'm going to add on the GOM text, and the text is basically going to be the outlier. So the outlier is basically either going to be the ID 40 or the ID 01, and then everything else is blank. So it's just going to output that. And this is just the formatting, the positioning of it and all, and this is just the size. That's all I'm doing here. And I'll do this as a Windows here, and this is just a nice way, and I'll maximize that here. And this is what we end up with. Okay, so I think that's quite a nice graph, and it's definitely something I would use on a regular basis in my own work. So I'd have the obviously the boxplots, but essentially it's just labeling the outliers. So now I know, look, that the 40th participant was an outlier at the start, the first participant was an outlier at the end, and that's just I think quite useful. And obviously once we have them highlighted, now they're obviously worth exploring. That obviously would be part of our data analysis plan and stuff like that, that now the outliers are going to be explored to see, look, are they typos, or what's the rationale for them, and so on like that. Okay, but look, that's it for this. I think that that's all the points I wanted to cover. Like always for these videos, so if you like the video, if you find it useful, then please like below, or you can share with friends. If you have any ideas for future videos, or maybe you've come across Boxplots in your own work and you have maybe one or two, you're looking for some script that might help you kind of format your own Boxplots, then don't be afraid to put some comment below, and I'll address it as soon as possible. Okay, but for now, all the best.